Hello, this is Mrs. Edwards, and we are going to do the review and preview problems 7-6 to 7-11 in the Core Connections Geometry book. When we look at 7-6, it says examine triangle ABC and DEF below. A says, assume that the triangles above are not drawn to scale. Complete a flowchart to justify the relationship between the two triangles. So when we complete a flowchart, we want to state all of the facts that we know about these two triangles. We know that side AB is equal to 14 and side AEF is also equal to 14. Looking at our triangles, we know that a triangle adds up to 180 degrees. So if I am looking for angle CAB, we can state that the measure of angle CAB is equal to 180 minus 39, minus 25. And when we subtract those, we get the angle is 116 degrees. Likewise, we can look at triangle DEF, and we can say that the measure of angle EFD is equal to 180 degrees minus 116 minus 39, which tells us that that is in fact 25 degrees. We then know if the measure of angle EFD is 25 degrees, that we can then conclude that the measure of angle EFD is equal to the measure of angle ABC, because they're both 25 degrees. We can also conclude that the measure of angle CAB is equal to the measure of angle DEF, because those are both 116 degrees. Using all of this information, we can conclude that these two triangles, triangle ABC, is congruent to triangle EFD by either the angle-side-angle congruency theorem or the angle-angle-side congruence theorem. So we completed our flowchart, and now we need to find the side lengths. So when we look at our triangles, across from the 116 degrees is side DF, across from the 116 degrees in triangle ABC is 20. So we know that the side length of DF is equal to 20. However, when we're looking for the length of AC, we do not have special right triangles, so we need to use the law of cosines. The law of cosines says that if we call this side B, we are going to B squared is equal to side A squared plus side C squared minus 2 times the length of side A times the length of side B times the cosine of the angle opposite, so times the cosine of angle B. So when we plug that information in, B squared is equal to side A is 20 degrees squared plus side C is 14 squared minus 2 times 20 times 14 times the cosine of angle B, which is 25 degrees. When we type this into a graphing calculator or calculator, we get B squared is equal to 88.467 about. When you take the square root of both sides, you get B is equal to 9.4. So the side length of AC is about 9.4 units long. 7.7 says use the relationship in the diagram below to find the values of each variable. Name which geometric relationship you used. So when we are looking at our picture, if we want to find the measure of angle B, we need to find a couple other things before finding B. So looking at our picture right here, these vertical angles will be the easiest thing to solve for first. So if we add 37 degrees plus A, because they're vertical angles, it should equal 63 degrees. When you use your inverse operations and subtract, you get A to equal 26 degrees. You then, because we have alternate interior angles, can determine that C is also 26 degrees, and that reasoning was angle A and angle C are alternate interior angles. So now that we have C is equal to 26, we can find B. 52 plus 26 gives us 78. If we're looking at this bigger triangle, B we can find by doing 180 minus 78 minus 37. So we then can conclude that the measure of angle B is 65 degrees because all the angles inside a triangle add up to 180 degrees. And then looking at if we look at this smaller triangle, we know that supplementary angles add up to 180 degrees. So if we can find this missing piece, we then can say that angle D and that circled angle are supplementary angles. So we can do 180 minus 65 minus 52 to give us this angle right here is 63 degrees. So it didn't ask us for that angle, but once we find that, it'll be helpful in order to do supplementary angles, which means 180 minus 63 tells us that D is 117 degrees. 7-8 says a rectangle has one side with a length of an 11 and the diagonal is 61 millimeters. So if we draw a rectangle and we label our information 61 millimeters and 11 millimeters, we are working with a right triangle, so we can do a squared plus b squared equals c squared in order to find our missing side. So a squared plus 11 squared equals our hypotenuse 61 squared. 11 squared is 121. 61 squared is 3,721. When we use our inverse operation, subtract our 121, we get 3,600. To undo a square, we square root, and the square root of 3,600 is 60. So we know that our width is 60 millimeters, but then they asked us to find our area. So remember, area of a rectangle is our base times our height. So we know our base is 60 millimeters. We know our height was given as 11 millimeters. So we know that the area of our rectangle is 660 millimeters squared. 7-9, Troy is thinking of a shape. He says it has 4 sides and none of those sides have equal lengths. He also says no sides are parallel. What is the best name for his shape? Well, if we have 4 sides and none of the sides are parallel and none of them have equal lengths, the best name would simply be a quadrilateral. Seven 10 says, without using your calculator, find the exact values of x and y in each diagram below. So what I would do first is I would draw myself a picture of my special right triangles. In a 30, 60, 90 triangle, the leg opposite 30 degrees is x. The leg opposite of 60 degrees is x times the square root of 3, and the hypotenuse is 2x. In a 45, 45, 90 triangle, the legs are both represented by x's, and the hypotenuse is x times the square root of 2. We then can apply that to find our missing pieces of our triangle. So if we take our 30, 60, 90 triangle, we know that 9 is across from our 30, so that's our smallest side. In our little triangle, that is x. So we know our hypotenuse, or x, is equal to 2 times 9, which would give us 18. Our y then, we are going to take our side opposite of 30, which is 9, and we are going to multiply that by the square root of 3. So y equals 9 root 3 is the exact value. When we look at letter B, we're talking about a 45, 45, 90 triangle, so we know that our legs should be the exact same size, so y is equal to 24 units. And we know that our hypotenuse should be our leg times the square root of 2, so x is going to be 24 roots of 2. When we look at letter C, we have a 30, 60, 90 triangle. So 30 is across from our x, and we know that our base, or what's across from our 60, is equal to x root 3. So we can set 8 equal to that, and then we can solve. So to get x by itself, we're going to divide by the square root of 3. And now we have a radical in our denominator, which is not simplified. So we rationalize that by multiplying both the numerator and the denominator by the square root of 3. And we get 8 root 3 over 3. And we just solved for x. And then in order to get our hypotenuse in a 30, 60, 90 triangle, we are going to take our x value and multiply it by root 2. So if we have 8 roots of 3 over 3, and we multiply that by root 2, which is over an invisible 1, whatever's on the outside of our radicals, we multiply together. Whatever's on the inside of our radicals, we multiply together. Multiply your denominator or your fractions straight across. Except you need to be very careful, because when we multiplied by the square root of 2, we were actually looking at the 45, 45, 90 triangle. We need to multiply our x by a whole 2. So it's okay to make mistakes, just cross it out and rewrite this as 2 times x. So if we do 2 times 8 root 3 over 3, we get 2 times 8, which is 16, root 3 over 3. 16 is not divisible by 3, so we have what y equals in the simplest form. 7-11 says solve each system of equations below if possible. If not possible, explain what the lack of an algebraic solution tells you about the graph of these equations. Write each solution in the form xy. So when we look at these two lines, we have the line y equals negative 2x minus 1, and we also have the line y equals 1/2 x minus 16. So I'm going to use the equal value method to solve this system and see, do these lines intersect at one point? Are they the exact same line, or are they parallel? So because they're both solved for y, the equal value method means we can set them equal to one another. We then want to use our inverse operations to combine our like terms. So I'm going to add my 16, and I get negative 2x plus 15 is equal to 1/2 x. I then want to multiply everything by 2 to get rid of my denominator. So I have negative 4x plus 30 is equal to 1x, because these equal one whole and cancel one another out. And then I'm going to use my inverse operations to combine my like terms. So I get 30 is equal to 5x. Divide by 5 and I get x is equal to 6. I do now know that my two lines are going to intersect at an ordered pair, so a point, and I found the x value of that ordered pair, but in order to find the y value, you need to substitute that x value into one of the original equations. Negative 12 minus 1 more gives us negative 13. So the ordered pair 6, negative 13 is where these two lines will intersect. Looking at letter B, we can also use the equal value method because they are both solved for y. So if we have negative x squared set equal to x squared plus 1, I'm going to combine my like terms using inverse operations. So I have negative 2x squared equals 1. Divide by my negative 2 to get x squared is equal to negative 1/2. And now we get to the point that no matter what number I plug in for x, I cannot multiply it by itself to get a negative. So no squared value will ever be negative. So this is not possible. So these two parabolas will never intersect. One will be opening up, one will be opening down, but they will not cross.